Now, section 5 of API 577 is welding materials. So, welding material refers to many materials that are involved in welding operation, including base metal, filler metal, and metal fluxes and welding gases. So, metal fluxes are generally going to be slags that are going to protect your weldment, and in the process where you're not using slag or flux, then you'll be using a shielding gas. If any, as each of this material impact the welding procedure specification and the weldment mechanical properties, an understanding of the convention used in ASME section 9 is necessary to adequately review the qualified welding procedure. So first thing we have seen in ASME section 9 is going to be P number for base metal. So we have seen there was a huge table for P numbers. P numbers were generally used so that you don't need to make multiple WPSs. So the base metals are qualified and assigned as P numbers in ASME section 9 to reduce the number of welding procedure qualifications required. So the main reason of you having a P number is that you don't need to do multiple WPSs or multiple qualifications for the welding procedures. For ferrous metals, having a specified impact test requirements, group numbers within the P numbers are assigned, which may become essential variable under certain circumstances. So we have already said where impact testing is required, these supplementary variable will also now become essential variables. These assignments are based on the comparable base metal characteristics such as composition, weldability, and mechanical properties. So these are some description of the P numbers that are given in ASME section 9. So steel and steel alloys are from P number 1 to P number 11, including P number 5A, 5B, 5C, and 15E. Aluminium and aluminium based alloys are going to be P number 21 to 25. Copper based alloys are going to be from 31 to 35. Nickel based alloys are going to be 41 to 47. Titanium based alloys are going to be 51 to 53. Zirconium based alloys are going to be 61 to 62. The same way how base metals are given P number, the filler metals are given F numbers. So electrodes and welding rods are assigned F number to reduce the number of welding procedure and performance qualifications. The F number grouping are based primarily upon their usable characteristics, which fundamentally determines the ability of welder to make satisfactory welds for a given process and a filler metal. Next, for filler metals, you also have something known as AWS classifications. So an AWS classification number identifies the welding electrode and welding rods. The AWS classification number are specified in ASME section 2C. Under the appropriate SFA specification number, the ASME section 9 table QW 432 lists the AWS classification number and SFA numbers included in under each F numbers. The noted X's are AWS classification represents E6010. So E6010 means that E is electrode, 60 is strength in KSI, 1 is the position, and the last 0 is coating characteristics. Same thing with 7010, 8010, 9010, 1010. This means that 7010 is going to be stronger than 6010, 8010 is going to be stronger than 7010, 9010 is going to be stronger than 8010, but all 4 electrode have the same position and same coating characteristics. Okay. So A number, to minimize the number of welding procedure qualifications, steel and steel alloy filler metals are grouped according to their A number. The A number grouping in ASME section 9 table QW442 is based on the chemical composition of the deposited weld metal. This grouping does not imply that the filler metals may be indiscriminately substituted without the consideration for compatibility with the base metal and the service requirements. This means you cannot directly change the material to a different, to a similar F number, provided that you have understood that the material will be compatible, it is going to have a good amount of weldability with the material that you are welding. If it's so, then you can substitute it. Okay. Filler metal selection, the inspector should verify the filler metal selection is appropriate for the base metal being welded. Some consideration are as follows: chemical composition of the filler metal, tensile strength of the filler metal and base metal, dilution of the alloying elements from the base metal, hardenability of the filler metal, susceptibility to hot cracking, corrosion resistance of the filler metal, and toughness requirements. Consumable storage and handling. The welding consumable storage and handling guidelines should be in accordance with the consumable manufacturer's instructions and guidelines and as given in AWS A5.xx series of the filler metal specification. Covered electrode exposed to moisture can become unstable during the moisture pickup by coating. Particularly susceptible to moisture pickup are coatings on low hydrogen electrodes and stainless steel electrodes. The moisture can be a source of hydrogen which can cause weldment cracking. So in most cases, the welding electrodes that are used, they are generally heated prior to the use. So the reason for them heating up is that whatever moisture is entrapped inside the coating shall be removed before you do the welding operation. If not, then it might do potentially hydrogen induced cracking or delayed cracking later on. To reduce the exposure to moisture, the certain welding consumable should be stored in a heated holding ovens after they have been removed from the manufacturer's packing. Low hydrogen SMAW electrodes are categorized by their final identification number, that is 5, 6 or 8, and are supplied in a non-hermetically sealed containers. Some manufacturers recommend that these electrodes be warmed prior to the specific temperature requirements prior to the use. The electrode should be stored separately from the other types of electrode with higher hydrogen content, such as based on cellulose based electrode, that is 6010, 6080, and these can be primary source of hydrogen pickup. Some welding consumables that are slightly damped can be reconditioned by baking in a separate special ovens. Any electrodes or flux that have become wet should be discarded. Section 6 is going to be talking about welding procedures. We have talked about welding procedures very extensively when we talked about ASME section 9. But again, this would also talk about welding procedure. The most things are going to be referred to ASME section 9. So qualified welding procedures are required for welding fabrication and repair of pressure vessel, piping, tanks and other items. The various codes and standards exist for the development of the welding procedure. This section reflects the criteria described in ASME BPAC section 9. The welding procedure qualified to ASME section 9 are required by the ASME inspection codes for both fabrication and repair. However, the construction code and proprietary company specification may have additional requirement or allow specific addition or exception, so they should be reviewed for each inspection application. The welding procedure required by the ASME section 9 includes a written WPS and an attendant document that is known as PQR. So you have a WPS that is qualified by a PQR. The purpose of the WPS is to provide specific direction to the person applying the material during the welding process, as well as defining the parameters for welder or welding operators. The WPS also provides the information to the welding inspector to measure the weld against the relevant WPS. So once the WPS is made, now we'll talk about PQR. The PQR is a record of the welding data and variables used to weld a test coupon and test results used to qualify the WPS. The purpose of the PQR is to demonstrate that the joining process proposed for the construction is capable of producing joints having the required mechanical properties for intended application. So we have said that we'll be doing tensile test, bend test, all of these tests are going to be the part of PQR. It is important to differentiate PQR from the welder performance qualification detailed in section 7. The purpose of the welder performance qualification is to provide the record of welding variables and results of the test conducted on the weldment to establish that the welder is capable of making the acceptable quality weld using the appropriate WPS. So 6.2 is WPS. So ASME section 9 requires each organization to develop a welding procedure used for fabrication or repair of the components. The complete WPS for a welding process shall address all essential, supplementary essential and non-essential variable where impact testing is required or when specified by the end user. The essential variables affect mechanical properties of the weldment. If they are changed beyond what is reference code paragraph allows for the process, the WPS shall be requalified. Non-essential variable do not affect the mechanical properties of the weldment, so they don't need to be requalified. When they may be changed on the WPS without requalifying the procedure, when supplementary essential variables apply or when the specified by the end user, they shall be treated as essential variables. Types of essential variables. So this is the entire table. We have talked about this in ASME section 9 also. For SMAW, what are essential, what are supplementary essential and what are non-essential variables are given here. This is for GTAW process, essential, supplementary, non-essential variables. It's for GMAW, essential, non-essential and supplementary essential variables. This is for submerged arc welding. The same thing we have seen in section 9. This is for plasma arc welding, electrogas welding. Next, PQR. So PQR record is essential when impact qualification is required. Supplementary essential variable used to weld a test coupon, the coupon test results, and the manufacturer's certification of accuracy in the qualification of WPS. The record of non-essential variables used during the welding of the test coupon is optional. However, it is an excellent quality practice to record all process dependent parameters. Non-essential variable addressed in the PQR must also be addressed in and within the ranges it is allowed on the WPS. ASME section 9 requires that the manufacturer supervise the production of the test weldments and certify that the PQR properly qualifies the welding procedure. The test sample selection and the testing requirements are defined in ASME section 9. Typically, they include a tension test to determine the yield strength and the ultimate tensile strength of the groove, guided bend test to determine the degree of soundness and ductility, notch toughness test to identify toughness requirements, hardness measurement to identify hardness restrictions. The yield strength may also be reported if any test specimen fails, the test coupon fails, and the new weld must be made and tested. The format of the PQR is not fixed, provided it addresses all the essential variable and the supplementary essential variables necessary. A sample form is given in ASME section 9. A PQR should accompany a WPS and be available to review at inspector's request. It does not need to be available to the welder. One PQR may support the various WPSs, and one WPS may be qualified by more than one PQR within the limitations of the fabrication code. Our main job as a authorized inspector is going to be reviewing the WPS and PQR. So inspector should review WPS and PQR to verify that they are acceptable from the code perspective and applicable to the welding to be performed. The initial step is to verify that the WPS has been properly documented and addresses the requirements of the section 9 and on the construction and repair code. The second step is to verify that the PQR has been properly performed and documented and addresses all the requirements of section 9 and the construction repair code. The third step is to confirm that PQR essential variable properly support the ranges specified in the WPS. The review shall document that the PQR variables represent and support the range specified in the WPS for production application. The NXE provides the checklist used for reviewing the WPS and PQR. Tube to tube sheet welding procedure. Tube to tube sheet welding procedure. Therefore, the tube to tube sheet welds may have many factors affecting weld quality that are different from those of the conventional grooves and fillet welds. These factors are mainly unique to the geometry of the weldments. Therefore, a demonstration of a mock-up in accordance with ASME section 9 QW 193 may be required for construction code for proprietary company specification. These are some essential variables. Procedure qualification test for tube and tube sheets. These include visual, dye penetrant, macro examination, hardness testing, shear wave load accordance with ASME section 8 division 1 annex A. So this was section 5 welding materials, and section 6, so it is WPS PQR as per the requirements of ASME section 9. So we have already talked about ASME section 9, so we have already seen these things. Now in the 7th section we'll go for welder qualification. We have also seen this in ASME section 9. So ASME section 9 Article 3 lists welding processes separately with essential variable that apply to the welder and welding operator performance qualifications. Unlike WPS PQR, the welder performance qualification is only limited by the essential variables. See section 9 QW 350. It should be acknowledged that the essential variables for the WPS are separate from the essential variables of the WPQ. The welder is required to weld to perform the production welding within the limits of the welder's WPQ. ASME section 9 QW 423 provides the range of the base metal qualification P number based on the P number used for the welder qualification. Filler metal F number fundamentally determine the welder's ability to make satisfactory welds with a given filler metal. The F number are provided in ASME section 9 QW 432. It is important to note that the WPQ is used to document the welder's or welding operator's ability to make sound welds as per the qualified WPS. Welding and welding operators. The welders and welding operators who are qualified to weld in accordance with one qualified WPS are also qualified in accordance with the other qualified WPS using the same welding process. within the limit of the essential variables of QW350 for welders and QW360 for welding operators. Examination failure of the production weldment, we have already seen this. So if the welder is to be qualified as per the production welds and failed to meet the standards, the welder is considered to have failed WPQ. The rejection weld will be examined in its entirety and the repair by the qualified welder or welding operator. Retest, an immediate retest may be granted if the conditions of ASME section 9 QW320 are met. Expiration, revocation and renewal of welder or welding operator qualification. The performance will expire or be revoked if the welder or welding operator is not welded with the specific process for a period of 6 months or more, or there is a specific reason to question the ability of a welder or a welding operator to produce the production weldment that meets the specification of the WPS. Welder performance qualification. The WPQ addresses all the essential variables listed in QW350 of ASME section 9. A welder may perform a qualification test that may incorporate more than one welding process. The performance qualification test coupon is to be welded in accordance with the appropriate qualified WPS. The welding is to be supervised and controlled by the welder's employer. The qualification is specific to the welding process used. Each different welding process or the combination of a welding process requires a specific and a separate qualification. A change in the essential variable listed in the welding process will require the WPS to be requalified and the welder to qualify that WPS. ASME section 9 QW352 through QW357 are the essential variable referencing the code paragraph for the different welding processes. The variable groups addressed are joints, base metal, filler metal, position, gas, electrical characteristics. We have already seen this as essential variables. The record of the WPQ test includes all the essential variable and the type of test and the test results. The range is qualified. The format of the WPQ is not fixed, provided it addresses all the required parameters. An example of the form is given in ASME section 9 QW484A. The required mechanical test performed on a welder or a welding operator qualification test coupon are required by ASME section 9 QW452. If a radiographic examination is used for the welder or welding operator qualification, a minimum length of coupon should be 6 inches and include the entire weld circumference for the pipe coupons. The coupons are required to pass visual examination and mechanical testing if used. Alternately, the welding and welding operators making the groove weld using GMAW, SMAW, GTAW, SAW may be qualified by using radiography for the first production weld. For welders, a minimum 6 inches of the length of the first production weld must be examined for the performance qualification and a minimum of 36 inches of the length must be examined for welding operators. There are rules for immediate retesting of the welders and welding operators who have failed the qualification test. This is commonly referred to as 2-for-1 rule, whereby the welding or welder operator tested on successfully complete twice the original number of tests. So if he fails one test, he'll generally do a test on 2 specimens. The welders or welding operator who failed any part of the second test typically have to be retrained. However, no clear guidelines is provided to the inspector regarding what constitutes as retraining. Documented evidence of retraining and production of the acceptable practice welds are presented to the inspector for approval before allowing the further test. Welder performance qualification expires if the welding process is not used during any 6-month period. The welder qualification can be revoked if there is a reason to question the welder's ability to make a sound weld or a code compliant weld. The welder's log or continuity report can be used to verify the welder qualification that have been remaining current. How to review the WPS? So these are the points that you, how to review WPQ, these are the points generally used to review the WPQ. Prior to any welding, the inspector should review the welder's WPQ and to verify that they have qualified to perform the welding given its position, process and other limitations. When reviewing the WPQ, the items to check include welder's name and stamp number, welder's welding process and type, identification of the WPS, backing used, P number of the base metal, thickness of the base metal, filler metal SFA number, filler metal F number, consumable insert if it's used, deposited thickness, welding position, welding vertical progression, backing, shielding and trailing gas that is used, metal transfer mode if GMAW, weld current and polarity type if it's GTAW, weld if the machine used, guided bend test results, visual examination results, additional requirement of construction code, testing organization identification acceptance via signature and date, radiographic results if it's used. Verifying the qualification ranges for ASME section 9 reference should be used to verify the qualification ranges. Base metal qualification in these sections, backing in these sections, deposited metal thickness in these sections, groove weld small diameter limits in these sections, position and diameter limit in these sections, and F number in these sections. Okay. So this was all for sections 5, 6 and 7, which was generally related to welding materials, that is P number, F number, WPS, PQR and welder performance qualification. In the next video we'll go for non-destructive examinations. The types of non-destructive examination can be done on a welding, and what kind of defects you can identify by what kind of non-destructive examination. So that's it for this video. In the next video we'll go for section 8, that is non-destructive examination.